I'm going to start by creating a folder called blueprints. In that folder, I'm going to make a actor called door. I'm going to create a blueprint interface. Just call it BPI door. And I'm going to add a function called interact. Which you don't need to pass in any parameters. Inside of door, I'm going to add a static mesh for the visual element. Well, actually first, I'm going to add a scene root and add a static mesh. So this is the door root and the visual mesh. For the purposes of this tutorial, I'm just going to grab any box mesh I have. Here's one I found, and just add a white texture to it, or any texture, and make it look like a door. So this door root is going to control how the door rotates. So we need to make the door, we need to have the visual mesh up like this, and then to the right. So the root is in the bottom left of the door, like so. Okay. Now we need to communicate from the player. So if we go to the third person character, whatever player you're using, and have it on left mouse interact. This is not the best way of doing it. Obviously you'd want to use the enhanced input system, but for now I'm going to do it like this and just do a line trace. Line trace by channel is fine, and I'm going to do it from the camera. Going to get world location and get forward vector. This is the start, and the end would just be the world location plus the forward location. Well, we're going to want to times this by right clicking, click convert to float, and this is the length of the trace. So I'm actually just going to make it 5,000. So when we left mouse click, we're going to do a line trace, and if that hits, if we break the hit result, if that hits something, then we're going to do I interact off the actor, the hit actor, yeah. So this is basically saying do a line trace into the world from the camera forward into the world, and if it hits anything, then I'm going to interact with it. If it's a door, I'm going to interact with the door. And then when it does hit the door, we're going to need to implement the interface inside of, by going to class settings, coming down here to implemented interfaces, and we're going to add an interface to the interface we made to BPI door. So let's add it to the door. Now we get access to the interface call I interact. So when this door is hit by the trace, it's going to interact with it, and this is going to be a client call right here. So what we're going to need to do for this to replicate is we're going to need to say to the server, this is an action that we want to happen for everyone. So we're going to send a message to the server that we want this to happen to everyone. So I'm just going to call this sInteract. So if this implements BPI door, because we don't want to just repeatedly send server RPCs for if we don't hit a door, because this is when we want this to happen. So we're going to pass in, this is going to be the door actor, and we're going to want to make this an actual actor rather than an object. So when we actually hit a door actor here, we're going to call sInteract and pass in the hit actor. So now this is happening on the server rather than the client. So the client clicks the input. This is a client here. This would come in as a client call. And then because the client owns the character, it can do a server call. So it's going to tell the server, I want to interact with this door. Now, when it calls this is going to be a server call, because we made sure to call it on the server. And now that's really important. So from here, we're going to want to do another custom event. And this is actually going to solve another issue, which is how we're going to have it open and close for everyone else. So if we just did a server call and didn't do a call here to open and close the door, if we didn't do a multicast, sorry, by hitting replicates multicast, then it wouldn't show for everyone else. So we're going to add a timeline here. This is the best way, I think, to do this. So we'll just call it open close timeline. And if you never use a timeline, basically double click into it, add a float track, and this, I usually call it alpha, right? Because it's used in the lerp. So we add 2 keyframes by right clicking, add a keyframe. We've got 2 on the screen, and we're going to make the length of the track 1 minute, sorry. Make this first keyframe 0 and 0. This next keyframe, make it 1 and 1. You can right click these, and if you change them to user, it has a little curve to make it a bit smoother when it's easing in and easing out. So we can use this now. We can call play from start, and this is just going to rotate. So S rotate or R lerp. Okay. And we want to use the shortest path. So this is where it gets a bit tricky, because we need starting rotation and target rotation. And we're going to be setting the door root here. Set world. Wow, we can do set relative rotation. Okay, update. And then when we finish, we can make a custom event here on door finished moving. We can, for starters, set to completely the target rotation. But you might want to do other things. You might want to check, is this open? Is this fully closed? And the way you could do that is you check the current rotation against the initial rotation. So if we did begin play, we could get the initial rotation here, which would be 0, 0, 0, but get relative rotation, and this is the initial, if I can type. initial rotation. And before I forget, type in replication into by clicking the highest hierarchy there and just clicking replicates to make sure it shows the changes for everyone else. And yeah, so you could check the get relative rotation here and check it. Is it equal to the initial rotation? And that means if it is, then that means it is back to the initial rotation. If it's not, then it's open. Right. So we call this on finish. So we have an event that gets called when it's finished. So the main thing that we have to work out now, what's the starting rotation and what's the target rotation? So the way I'm going to do this is a simple way, but in reality, you'd probably want to use the dot product to be able to check where the player is in relative to the door. So you could open it away from the player, and then you could pull it back into the player if it's already open. But we're just going to flip-flop. So the starting rotation would be starting rotation here would be if I get this and get the relative rotation. This is the starting rotation. And the end rotation, target rotation, would be this is the tricky part. So if I flip-flop, we could do it so, right. Okay, so we're gonna have to do some checks here. So if we do, okay, start rotation, if this is equal to initial rotation, right? If this is equal to initial rotation, we should give it a bit of an error, a tolerance here. We're gonna flip-flop to either initial rotation, we're gonna have to break this rotator and make a new rotation here. Make rotator. So everything's gonna be the same except for the yaw, because the yaw is, if I show you here, the yaw is when it's turned like this, but we're gonna be rotating this, so it rotates like this, rotating the root here. So it's either going to be plus or minus 90 on the yaw. So this is plus. And do another one, but instead of plus, it's going to be negative 90 for the other way. Right, so here we go. Move this up, out of the way, right. So here, so if it's equal to the initial rotation, so it's neutral, it's not opened or closed, it's going to make a new target here, which is going to be either plus or 90, or negating 90, right? Adding or subtracting. And then if it's not, we're going to make it neutral. So we're going to make the target rotation. We're going to make that neutral. Oh. Right. So if we look at this logic, we're going to set the rotation to the current relative rotation, the starting rotation here value. We're going to set this to the current relative rotation of the door root. And if that's equal to the initial rotation of the door root, which we set on begin play, that means we're opening it. So we're going to flip-flop in which way we open it based on this flip-flop right here, which basically just goes A and then B after each other, flipping and flopping, and it's adding or subtracting 90. Then it's going to play from start, and it's going to update. When it's updating, it's going to alert from the starting rotation to the target rotation, the shortest path, using the alpha from the timeline. And when it's finished, it's going to call on door finished, which you can do logic here. Right, let's test it out. So I'm going to put this door into the world. It looks kind of big, but that's fine. Okay, now I click, and nothing's happening. Let's check out why. So I'm going to make this persistence so I can see the line trace. So that's coming out. That's actually hit the door there, and it's not doing anything. Why is that? Interact. Oh, we're just of course. I'm not calling open or close. So I hope one of you watching, following along, realized I did that wrong. So now if I try again, okay, it's still not working. I'm doing this live, by the way, so there's probably going to be some problems. So if I do this, add some breakpoints is a good way to work out what's the problem, what's not being called, etc., etc. So bam, it's actually calling interact, and it's calling it on the door. As you can see, it's coming in, saying, okay, I'm being interacted with, open and close. Okay, so saying the initial rotation, the start rotation is 0, and is it equal to the initial rotation? Is equal to the initial rotation, so set the target rotation as 90 in the yaw. Oh, I see the problem here. I see the problem. So it's just setting the target rotation, but then it's not calling the timeline, which, so you could either loop, you could from here loop it down to here, which is a bit of a messy way of doing it. Another way you could do it is adding a sequence here. So it's going to do this part, and then it's going to come back down here. One part I missed. But we don't want to actually, we want to, for this logic, skip setting the target rotation to the initial rotation, because here we're setting the target rotation, we don't want to set it here for the initial rotation. Hope that's obvious why. Now we can get rid of these breakpoints here. We don't need them now, we know what's going on. And we can click play. And now that opens. Right, nice. So if I, now it should open the other way. So that's the basic logic. Let's just check if it's replicating. So this, for that, we click these little dots, go to net mode, and go to play as listening server. So it's going to spawn a client. Let me make sure the client's on the screen for you guys. Bring that here. So even if I'm the client here, I'm playing as a client. You can see it's a client because the net mode in the top bar. If I left click, it's opening for both the server and client, and it's very smooth. It's not like it's going to start doing weird things. Wait, that should have collided with me, right? Does that collide with the... Okay, that does collide with the server there. Oh, okay, that is moving my player character. I thought, for some reason I went through the door here, didn't I? Oh, that's doing something weird there. Yeah, that's doing something odd there. Why is that not replicating properly? Let's investigate that. So that might be because in my preferences, if I go to net emulation, no, there's no net emulation. So why is that doing that then? The only thing I can think of is I am not calling this as a reliable RPC, so it could miss the call for the client and be called on the server. Also, this isn't set to reliable. So if I set both these to reliable, let me see if the same problem persists. Which it shouldn't be an issue with no net emulation. Okay, that seems to have fixed it. Which is strange. That shouldn't really happen with no net emulation. Which, if you don't know what net emulation is I can basically simulate lag. So if I turn this to bad, my minimum latency is 100, and maximum latency is 200, and my packet loss percentage is 5. So that basically means that's incoming traffic and outgoing traffic. So that means there's potentially 400 latency. So I can simulate lag basically. If I turn that on, there shouldn't be any difference now. Okay, it's just a bit of a delay to when it happens, when the action actually happens. But as you can see, I went through the door then, so I think that is a bit of something to do with latency, the fact that my client can go through the door like that. But that solves all of these problems, so we have a way to communicate to the door from the player. That is the interface. We have the door opening and closing, that's replicated. That's using the timeline, and on door, close or open, you can do something. So if you want me to go through that again, just quickly, communicate. Let me look at the code. So we can communicate through the line trace and the RPC here, and we even talked about using reliable to make sure the call gets called. We have the interface call here, which is calling a multicast RPC, which is operating on this timeline, which controls the rotation, and then when it's finished, it's calling the door on finished event, where you could do logic like play sounds based on if it's open or closed, that type of thing.